Hi guys, welcome to the chapter of reflection of light. This chapter covers maximum in-depth of knowledge in minimum possible time. And we have a couple of questions here before us, which we are going to be solving and also giving you some other points that you needed to understand the topic of reflection of light in plane, curved, spherical, and parabolic mirrors. So we are going to start with the first question. If you find anything interesting, you can kindly subscribe and click on the notification button. We are starting with the first question. In the diagram, you can see a diagram. An incident ray, you can see incident ray AY makes an angle of 30 degrees with the normal XY. Normal is always perpendicular to surface. Very important. If the mirror is rotated anti-clockwise, I hope you have studied about that before. So this is the direction of rotation of mirror. Anti-clockwise about Y. So the mirror has now changed position. It has now been rotated anti-clockwise. So we are now, while AY is fixed. Okay, this particular point is fixed. The mirror, this mirror here, this mirror is now rotated about Y. So that means the mirror is shifting position. Do you understand my diagram? So I'm going to rotate it anti-clockwise. Then what angle will the reflected ray now made with the incident ray? Now, not to waste our time because we are not talking about derivation and concept. We are only giving strategies on how to solve questions very quickly in case you are facing such question in an examination. Now, important point under this you need to keep at the back of your mind is the angle of reflected ray or angle between reflected ray and incident ray, angle of reflected ray with the incident ray. The incident ray for anti-clockwise rotation is given as 2I plus 2 theta, where theta stands for angle of rotation and I definitely is the incidence angle of incidence, anyhow you call it. Now, basically, you might have studied also, I told you it is just about a quick concept class, not a full concept class, that from the laws of reflection, which is the first thing I think we have to keep in mind, the incident angle of incidence is always equals to angle of refraction. Incident angle is always equals to angle of reflection. Please excuse me with that. So, and the normal is always perpendicular to the surface. Incident ray, reflected ray, and the normal ray all lies at the same plane. So that's the basic idea. Then another important thing you can also keep in mind, if you have taken this for anti-clockwise rotation, in case of clockwise rotation, if it is clockwise, I am not here to teach concepts, just to solve questions. The new angle of reflected and incident ray, the angle between the two of them is now 2I minus 2 theta. I hope you are jotting down because it is important to keep that in mind. So if the question is only asking for the angle of incident ray, whatever angle answer you get here, you divide by 2 because the angle of incident is always equal to the angle of reflection. So that is the let me say one of the shortest cuts you can use with formula to get your answer. So that's about that. But understanding concepts, like I say, you can watch my concept video to understand how this is being done. So directly here, we are looking for the angle between the reflected ray and the incident ray. So it is rotated anti-clockwise. This is the formula I am going to use. So I change to blue. So directly we can say 2 times the incident angle was 30 plus 2 times the rotated angle is 20. On simplification, you have 2 times 30 is 60, plus 2 times 20 is 40. 60 plus 40 is going to give you 100 degrees. And that will be the answer to this question. So the answer to this question is 100 degrees, and that is the angle. Now, for concept wise, for those that have watched my concept video, there are other ways in which we do this, because we know if the ray of light is incident here, it will follow that path. We can trace out the deviation, but because of time, I said because of time, I may not be able to show all these stuff, but you can watch the concept video. But it is not needed for you to be honest. On Waec, most of your questions are direct based questions, and that is why it is very easy to pass. So we know it will be reflected along the same path with the same angle. Just for illustration's sake, if this is the reflected ray, I'm just trying to show you another way for those of you that love to know everything. This is also going to be taught as you have studied. Then there's another important thing that when mirror is rotated, the angle of what? Rotation angle. You can also keep this rotation angle, which I use theta, is always twice the angle of deflection. So that's another thing. So theta is also always equals to what? 2R. So you can also keep that in mind, because in question, a direct based question that you guys might have seen. So this thing will be deviated. You know, when I say deviated, that is the total angle from this point to this point. You have studied that before, as you have known that the angle here from here to here is 60 now. So this will be something like 180 minus 60. We know that very well. So 180 minus 60, 180 minus 60 is, if I'm not mistaken, 180 minus 60 is 120 degrees. So the angle here is 120 degrees. That's the deviation angle to be deviated. So the mirror is now rotated anti-clockwise by an angle of, what's that? By an angle of 20 degrees. So the angle that this will now, because it's now rotated, so the angle this one we make here will now be 30 plus 20, that is 50. So that is the way we do that. So if this is now 50, so the new angle of incidence will now be 50 times 2, and that is also 100. But that may look complex for those who don't understand concept. So directly, you can just apply this direct formula for UTM and Waec based question to get the concept. Another important point, I told you this is a quick concept class. The deviation angle, which I just used there, is always 180 minus 2 times the incident angle. That is what I did here. 180 minus just 2 times this is going to give me the deviation angle of the mirror. So these are important things you can just keep at the back of your mind. Reflection takes place in the mirror. Keep that at the back of your mind. So the next one, we have the magnification of the image of an object placed in front of a concave mirror. Now we are talking about what we call spherical mirror. An example of the spherical mirror is a concave mirror of is 1/3. So the magnification of that particular stuff is 1/3. Just listen, I'll take you through some other thing. Then we say if the radius of curvature of the mirror is 24. The radius of curvature of the mirror is 24. So radius is 24 centimeter. Now you can convert the radius of curvature to focal length. You might have studied that as radius of curvature is twice the focal length. So always keep that in mind. Now, the focal length, which I will write as f, will now be equals to -12. This is where something is. The question is, why am I using -12? I tell you, twice of the focal length is the radius of curvature. You can keep that in mind. Now, when we talk about the magnification, quick concept, very quick one. Apologies, my camera is still having fault. You know me, I love gesticulating. So my point is, if you look at the convention, there are 2 types of spherical mirror. It can be a concave mirror. It can be what? A convex mirror. Now, for a concave mirror, listen, guys, you just need to keep this at the back of your mind. It is always very important. So I said, oh, if this is concave mirror, is it concave mirror? I thought I was actually interpreting as a convex mirror. So let's take it. If it is a concave mirror, it will not be what? Negative. I was thinking this is a convex mirror. That was my interpretation. Sorry, guys. For convex mirror, it depends on the convection you want to use. Just get it. The convex mirror. I just want to keep you guys to write this down. Say the focal length, the conventional focal length I use is f is negative. And if f is negative, my magnification also will be negative. So keep that at the back of your mind. My team are telling me that this is a convex mirror, that it was a typo. So maybe I should help them to change it, because that's the signal they are giving me that it is a convex mirror. So because of the nature of the option. So if this is a convex mirror, this is what you are going to use. This is the convection of sign. Now, another thing I think I should talk about here, so that you don't make mistake when dealing with this. In fact, we say the nature of the image form on a convex mirror is VED. I think I should also talk about that, which means virtual, erect, and diminished. Virtual, erect, and diminished. So the image is always virtual, and it's always going to, when you say something is virtual, it means it will be behind the mirror. Quick concept: behind the mirror. So very important. It is erect means it is upright. Diminished means it's small. It is never going to be magnified. So those are important. So this is a sign convention I love to use. And you must also keep it in mind. I had a lot of things on my concept. I think the whole video for reflection of mirrors is about 13 hours for A-level student, right from the scratch to the highest level. You understand? But for your UTME and YF student, you only need to map out a quick concept, all this stuff. Now, when we talk about mirror formula, which you have also studied before, maybe I quickly talk about that here as well, because more going forward, I am going to be using what I have said here to solve the question. The mirror formula, the derivation is from your geometry, from graph. I may not be talking about that for now, and it's even beyond the scope of your syllabus for Waec and what UTME student. Or if you want to watch the derivation, you can always watch my concept video. Everything is there. So now, 1 over f is equals to 1 over v plus 1 over u has been what you guys are used to in terms of the what? The mirror formula. Mirror formula is just used, or let's say it's generally used, to know the exact distance of what? The exact position of the image of an object. Whereby we also define another thing we call magnification of a mirror. That is used to calculate the height of the image of the object that is used. Please always keep that at the back of your mind. I give it in my concept video as modulo of V over U, that is image distance over object distance. Now, most of your textbook will just write it as V over U. As you have seen it, it's the same thing. I'm only taking the modulus because I know about the sign convention. Now, again, we have also studied in the previous chapter, that is the 11, about the pinhole camera magnification. So we also relate magnification as the height of image over that of the object. So please keep that at the back of your mind. So that is another thing about magnification, which we have studied. So keep that at the back of your mind. Now, this is the basic formula I hope you have studied before. I'm supposed to solve this question, but now I'm teaching. So which is why you need to stay with us. Now, my point here is very simple. I can tell you that this is a formula, but there are different ways in which we can generalize mirror formula. Another important note you can just click on this mirror formula is that mirror formula is only applicable for parasial ray. Parasia. This is it, parasial ray. When I say parasial ray, now it means what? It means rays that are close to the principal axis of what? Rays that what? Objects that what? That are what? That the size is very, very small. So they are only applicable for parasial rays close to principal axis. Principal axis. You know, you have studied about principal focus of mirror, which can be defined in two ways. The ray parallel or close to the principal axis appears to what? Converge or diverge. We are still going to talk about lenses, which is refraction of light. I'm not teaching, but it's like I am just teaching now because I want you guys to have full understanding. So when we say it's applicable for parasial ray, it's only applicable for objects that the sizes are what? Are very small, are small. You cannot use mirror formula or magnification formula for objects that are what, that the sizes are big. Keep that at the back of your mind for non-numerical type of question. So to solve this is very simple, because the team told me now, they are with me, that this is a convex and not a concave. If it is a concave mirror, I'm not going to change anything here. So we have different ways in which we can now rewrite or generalize formula. That is the point I want to make the other time. So generalizing the formula, guys, we can say now, 1 over f equals to 1 over v plus 1 over u. You can now generalize the formula in different ways. One of the ways is what you can make f solve a formula. If question asks you to find f, you can always keep it at the back of your mind. It is uv over u plus v. I hope you are there. You can also generalize v as equals to uf over u minus f. And if you have generalized v, you can also generalize u as vf over v minus f. So these are other ways in which you can directly calculate a given value when they are given in terms of what, the parameters. So if you know the generalized form of your mirror formula, this is the mirror formula we have generalized. Similarly, if you have generalized that, you can also generalize the magnification of a mirror in terms of what, this mirror formula. Doing so, my dear student, magnification can also be generalized in different ways. For example, it is equals to, I can say, f, the focal length, over u minus f. One way to generalize it. Another one, I want you guys to write all these because they are important. You can also say m, if I substitute, is equals to, I can say this is v over f minus 1, which is the most important thing. In fact, when you want to talk about graph of magnification, it's always going to have a negative intercept. Magnification with respect to what? Image distance. You can see it's direct proportional to it. Y is equals to mx plus c. You can see that the negative or the c is what, -1. So that is why when you draw the graph of magnification, you can see I'm teaching and I'm not supposed to be doing this. It's always going to give you a straight line curve with negative what, intercept. You can see negative intercept. So whenever you draw the graph of m against what, against v. So these are things you keep in mind, please. I hope you have written that for you to be able to solve questions. So these are the way we will interpret or generalize. You can also generalize it in terms of radius of curvature. You can say it is equals to m is equals to, I'm just giving you this formula for direct application of direct based question, r over, this will be 2u minus 1, or 2u minus r. What I've done here is just, I know r equals to 2f, I have only substituted. So all these are generalized form of magnification, and these are generalized form of mirror formula, which you can also write down as a note for direct question that asks for focal length when all these parameters are being given. So back to question. Sorry, we have to just move that way. It's normal for understanding's sake. Now that we have studied the generalized formula, and we have also studied how to calculate, this question asks us to find the distance of objects when we know magnification as -1/3, convection of sign. I've talked about how sign convention is being used also on my concept video. As has gone, this have to come back. Yes, I think it's back. So let's manage here. So from here, I have magnification, I have object distance. I have the focal length rather. So I'm looking for the object's distance. So the distance between the object and the image. Let's calculate u. I think this will go now. Let's use this. M is equals to f over u minus f. M is -1/3. As it is convex according to the Mosdy team, focal length of this is also negative. We have done that because we divide radius by 2 to get the focal length. We are using -12. From your mathematics, u minus 12, that is plus 12. I have only done the normal rule I expect you to know. On simplification, you are going to get here u will be equals to, I'm doing that for you to see. You can see this is -36. 12 times 3 is 36. This is -u minus 12. As you can see, it's -36, -u minus 12. So u will be 36 minus 12. Please, you can try it out. All what I'm doing are what you can do because of space. 36 minus 12 is going to give us nothing but 24 centimeter. That's 24 centimeter. So let's get that 24 centimeter. What I've done here, I cross multiply and I simplify. 36, then when this comes to the other side, it will give me 24. centimeters. So keep that at the back of your mind. The question says, what is the distance between the object and its image? This is the object distance. I need to get the image distance. We'll talk about magnification as what V over U. So if I have gone with the same formula of magnification, 1 over 3, remember the negative, is V I am looking for now over U, which is 24 I just got. From here, I can see that my V will be equals to -8. I hope you are there, centimeter. If I have cross multiplied here, and that shows me that what the image is formed behind the mirror. The image is formed behind the mirror. That is the interpretation of that. I'm not wasting your time, guys. I'm only trying to let you know that this aspect is kind of clumsy, and that is why I'm giving you the best way in which you can get all these things. So it is better you write them and form your short notes, not to make any sort of mistake. So I'm looking for the true distance between the image and the object. So the distance between the two of them will be, so distance between them, I'll just write it as the 24 plus 8. Somebody is asking me, why is 8 coming from here? So I will tell you, it is very simple. This is 32, and this makes this answer to be correct. The interpretation of -8 from sign convention means the image is virtual and it is behind the mirror. So it doesn't mean that when you are looking for the distance between object and image, you are going to say minus. No, it means you are looking for the total distance from image to object, which you might have also studied under the concept of plane mirror. So the answer to the second question here is 32 centimeter according to the options we have here. So I hope you understand, provided it is a convex mirror. If it is a concave mirror, this convection sign will be positive. So keep that at the back of your mind. I hope I am able to actually explain in details to the level of your understanding how I think you should be able to get there without any problem. So we move to the next one. We have 12 questions today, and I'm wasting a lot of time on that because I need to talk more and more about them. The next is a simple periscope is an optical instrument which dash Roman figure 1 comprises of two parallel plane mirrors. Roman figure 2 magnifies image of object. Roman figure 3 is used for viewing behind obstacles. I hope students knows that a periscope, let's just write a simple note for understanding, works or is one of the words, let's say application uses of plane mirror. Uses of plane mirror. So one of the use of plane mirror is a periscope. And when we talk about periscope, it's not the only one. We have common looking glass. You have the kaleidoscope. I hope you have heard about that. You have the sextant, which is used for navigation. I talk about kaleidoscope. Kaleidoscope is an important thing. We can have another thing they call mirror galvanometer. You use a plane mirror for it. Mirror galvanometer. And the normal looking mirror or glass, which you use to check what your beauty. Now, my point is, how does a periscope work? It works, all these works on the what as an application of what? Of plane mirror. So a periscope is just a kind of instrument, or we say optical instrument, that has two plane mirrors. It consists of two plane mirrors that are inclined at an angle of 45 degrees to each other. Two plane mirrors inclined at an angle of 45 degrees to each other. So I think you need to understand this. It is generally used to view objects above and below an observer. It is something that most of you've come across before. I'm sure about that, especially guys that watch football match. You have seen a periscope before. It's simple to explain. It's just a normal, I don't want to be drawing because of time. But if need be, I think I need to just let you know how it is being. Oh, wow. So it is just a very simple, let me use just, I will turn it back. Diagram not down to scale. You can see the first one, 45. The other one will now be inverted right angle triangle. I know you've seen it before. So which is also inclined at an angle of 45, something like this. I'm not drawing anything to scale. So that is why I just want you guys to see the first one and the second one are positioned in such a way that they are at angle 45 degrees to each other. So keep that in mind. So what it does in the football pitch, you guys have seen it. It's been what it moves around from one point to another. So it can check objects behind an obstacle. It can be used to actually see something behind because it has plane mirror up and plane mirror down. So objects above and below an observer, you use a periscope. So sectants are used for navigation. These are used majorly. These also contain a plane mirror inclined at an angle of 60 degrees. It is used by to produce multiple image or multi-image of multiple color. These are basic things I think you have studied before, and if not, that is why I'm actually giving you other things you need to know about them. It is majorly used by all these fashion designers to produce multiple colors and stuff like that. Mirror galvanometer, we are still going to talk about other magnetic effect of currents. We're going to talk about all these moving coil galvanometer and the rest. But for now, mirror galvanometer also use what? A plane mirror, so that you can actually what? So that what the deflection of the scale of the needle can easily be detected. So that is just that for now. So keep this in mind. So this is a simple question. It comprises of two plane mirror. It's absolutely correct. Magnify the image of an object is a lie. Mirror don't magnify. Another important point. Mirror, plane mirror, plane mirror, plane mirror don't magnify image. Please note that lenses does that and other optical instruments. So you keep that at the back of your mind. Its use of objects behind obstacle is also correct. So we have Roman figure 1 and Roman figure 3. In fact, other characteristics of this is the answer of plane mirror is that it has the same distance and size. Image in the plane mirrors are upside down, laterally inverted. Junior classes, all this should have been talked about, and if not, that is why I'm still stating them again so that you can actually get them. So that is that about the third question out of 12. We have to increase our pace. The next question is a question on if an object is placed in front of two mirrors inclined at 90 degrees, how many images will be formed? I think this is just a direct stuff that you might have studied. When you talk about the formation of multiple image in the flame mirror, it follows a kind of what? The geometry actually follows a kind of circle. When we say circle, that is just the perpendicular bisector for the point of intersection of the image. Forget that because you don't need it. You are not advanced level student. So what you just need to keep at the back of your mind for you not to make this mistake directly is that which you most have studied in your junior classes is the number of images are 360 over theta minus 1. So we actually got that from what? The multiple image formed by what? By two mirrors. As we know that the angle where they are meeting, we always produce the image, which is always at the same distance from each other. So what I'm trying to say is that a plane mirror produces multiple image. And when they do that, or let's say a thick glass, let me say it better, produce multiple image. And when they do that, they have what? A locus, which is always what? A bisector of line between what the language. So don't worry about that. If those language you don't understand, what you need to understand for your level as at now is that the image form, the number of image form in the plane mirror, derivation has been done on my page. You can always check it out. And if you have anything, drop comments, but you could drop your comments in the comment section. I'm going to attend to. So the number of image directly is number of images n is equals to 360 over angle of rotation or at angle in which the mirrors are placed. You have two mirrors. Now, 90 degrees minus 1. I hope this is simple. So, 360 over 90 is 4. 4 minus 1 should be 3, which should be the question answer. Be careful about this type of question as well. Everything must always, if anything is divisible by 180 over theta, this is how we come about this. But in as much the angle is not divisible by 180, we say it is going to give an infinite image. So I think many of you also in your junior classes, you've studied this, whereby a situation whereby you have, when you sit down at the what we call the focus of a mirror, the image formed is at infinity. Example in your junior classes is the barber's shop. When you're in the barber's shop, you expect what an infinity. So when objects are placed at an angle of 0 degree or 180 degree, you can see what I'm talking about. You can see when 0 is under, you can see the image is what it is not divisible. It is what infinite. So keep that, and when it's 180 over 180, which is also parallel, it says what image forms at infinity. So I hope you are following this and you are getting it. So which is the most important thing? We move to the next question. Question 5. About question 5, we need to be fast. An object is placed at the center of curvature of a converging mirror. Let it be known that a converging mirror is the same thing as concave mirror. When we get to less, we also call it convex lens. Don't worry. For mirror now, keep it at the back of your mind. So the opposite will be diverging mirror. Is convex mirror. I told you the nature of image form on the convex mirror: vector, erect, and diminish. Vect. That is the interpretation we give to it in physics. So be that as it may. Now, when we talk about the second type of mirror, concave mirror, it is the one that is also kind of a spherical mirror that is silvered outside. Many of you have come across it, you know what I'm talking about. And we know from the principal, this is the principal axis, then image that is passing through what? That is what? That is coming from what? From any point, and it is incident on the mirror, must always pass through the what? Focus. So we say this is the center, the focus. So it depends on the position at which you place the mirror, the object. Will tell you the position at which the object, the image is going to perform. Now, image are classified into two. You can see what I'm talking about understanding. Now we are in the aspect that we have to talk much, and I have to do that. Real and virtual image, we talked about that. Real image are formed by actual intersection. They can be seen on screen. Image formed on screen. They exist. They are real. This one, they are not form of fake. They seem to exist. So you can just keep that in mind because all these are important things you need to keep at the back. My point is now listen to the important thing now. Most of you know photocopier machine, Xerox machine. In Xerox machine, when objects are always try to set, those of you that operate photocopier machine, you know what I'm talking about. When you place object at the center, you place the paper at the center, you are going to see the exact image. So whenever object is placed at the center of curvature, image is also formed at the center of curvature. That is just the logic. You can just quote me. When object is placed at the center of curvature, at the center here, image will be formed at the center. If object is placed between the center of curvature and the focus here, the image will be what? Will be at the back of C. Image will be formed at the back here, beyond C. You can see at the back of C. But if object is placed at the back of C, just quote me, image will be formed between C and F. And the last one, this is the pole. We call this one the pole. If object is placed between F and P, this is when you have what? A virtual image. So the only time you have a virtual image on the convex lens is when object is placed between F and P in a concave mirror. Image form is virtual. So I hope you understand now. So other type of situation or cases will give you a real image, but the only thing is the size. For this one is the same size and the same distance. Photocopier machine. So object at center, image. Now when object is placed at F, we say image don't meet. I just explained that one in the previous chapter. We say image meets at infinity. Infinity. So I hope you understand that, and here to answer this question now from all what I've been saying since morning, I think it's not a very simple question. An object is placed at the center of curvature of a concave mirror, which is also called a converging mirror. Its image will also be at what? At the center of curvature. So that's the answer to the question. When you know it, you know it. So that's just that. The next one is an object is placed 6 centimeters in front of a concave mirror. This is a mirror that I think my team are making mistake. Nowadays, we just need to be careful of focal length of length. The image form is dash. We have look at the parameter we have. We have object distance 6. U is 6. We've talked about this before, so we just need to solve. We have F to be 9 centimeters. So we are looking for V. So the generalized formula we use here is V is equals to UF over U minus F. So on substitution, we can say UF, that is 9 times 6 or 6 times 9 over U minus F, 6 minus 9. My answer is going to be a negative, and you know what that negative means, my dear students. It means the image is behind the mirror. We've talked about that. This is 6 times 9 is 54. I hope I don't make mistake. And if I make mistake, correct me in comment box, 18 centimeters. So that is that negative 18 centimeter means the image is virtual. We talked about that. It doesn't mean that when you are adding or you are looking for the distance between the two, between the object and the image, you are going to subtract. Please keep that to the back of your mind. And it is 18 centimeter in front of the mirror. So always keep that at the back of your mind. The answer to this is choice A, and that is the right answer to this. I hope you are getting this. So we move to the question 7. Fine. The question 7 is just what I just explained now. I think I don't need to waste my time. You can see where the position of the object is placed. It's placed between F and P. I told you this is the only time where a concave mirror is going to give you a virtual image. Keep it at the back of your mind. So image will not be formed at the same point here. Image will be formed in front. Because virtual image are formed, you can see in front of you. So now, here we have the image of an object OY. Where is OY? This is OY. Okay, I think this is Y then. That look like S. It's formed by a mirror. Why are they writing mirror? Mirror as mirror. In the above figure is located as what I told you. A is between F and P. Image is not. When object is placed between focus and the pole, image is formed here. So now to the right of P, and see, right of P is the answer to this because I've talked about that in the previous one. To the left of C, all those ones, these are real image. Real image are formed at this side. Virtual are formed at this side. So guys, let's move on to the next one. You can see all their mirror is mirror, mirror, mirror. Maybe it's error from the team. Now, the next one is a ray of light strike a plane mirror at an angle of incidence of 25. Incident angle is 25 degrees, which will also be the reflected angle. Angle of incidence is equal to angle of reflection. The angle made by the reflected ray with the surface of the mirror is that angle between reflected ray and the what? And the mirror is what? It should be 90 minus 25. I don't think that one is a question that you guys should be solving, but at least if you don't know it, you have to explain it. So I think this is 55 degree because we said normal is always perpendicular to surface. You don't get it. This is what I'm talking about. This is the surface of your mirror. Ray of light was incident. Ray of light was incident. As it is incident, it will be reflected. Then the normal ray is always perpendicular. Perpendicular means it is 90 degrees to the surface. This is the normal. Normal is always perpendicular to surface. That's normal, my dear student. If that is normal, so what we are saying is this is 90 degrees to the surface. So normal is always perpendicular to surface. 90 degree, 90 degree. So if the angle of angle of incidence was 25, as the incidence with show arrow, it strike it should be reflected back. The reflection is also 25. So the question is, they are in degree. The angle made by the reflected ray, this is the reflected ray R, and this one. So we know the angle from here to here is 90. So 90 minus 25 is going to give us 55 degrees. So that is why I said the question is quite straightforward. Number 9 and number 10. Wow. Number 9, we have in the diagram, what is the reflection angle of mirror M2? As mirror, okay, we have multiple mirror, we have multiple image. That is what gives us the formula I told you the other time. Number of images 360 over theta minus 1. But I think this we want to do a little bit of geometry. So let's try and do the geometry well so that we can see. In fact, they did not put options here. I don't know why they refused to do that, but that doesn't stop us from getting the right answer. And that is why you need to understand them very well. So the ray of light was incident at M1. You can see angle of incidence will be angle of reflection. It will be reflected at the same part at the same angle of 30. We just talked about that normal is always perpendicular to surface. The total angle from here to here is 90. If this is 30, my dear students, this is going to be 60. A little bit of geometry is what we are doing now. So if that is 60 degrees, so that means the reflected ray of this one is the incident ray of mirror M2, multiple image form in T glass. Now we have, this is 60 degree will be the incident as alternate angles are equal. So angle of incidence of the second mirror must also be equal to angle of reflection of second mirror, which is also 60 degrees. So I think you understand this. So the angle of reflection in mirror M2, so M2 we have a reflection angle of 60 degrees. So that's the answer, guys, to that question, not to waste your time. Then question 10. Question 10 says, which of the following is true of image formed on a convex mirror? We've talked about this truth, so I think I can now rush you a little bit. The nature of image formed on a convex mirror is vague. In fact, we talk about another important thing. Maybe I should quickly talk about it for now. Now, convex mirrors are used as what? Car mirrors, because of what we call field of view of a mirror or of mirror. There's what we call field of view. That is the distance at which what they can actually see. So convex mirrors has a wide, we define that. I think I have the video. Yes, it's there available. How to calculate field of view. It is not needed for you guys, but for those of you that you are going for engineering courses and doing advanced physics, you can watch it at your leisure as well. So my point here is that convex mirror do produce this. We've talked about that, and they are used as camera because they are what they have this kind of characteristics and they have a wide field of view. So let's answer this multiple choice question. The first option says the image is always virtual. Yes, I talked about that. Absolutely correct. The image is always erect. Erect is always also upright. In case you see upright, the image lies between the pole and focus. Yes, that is why I told you image that lies between pole and focus is always going to be a virtual image. Remember this? You can say focus and pole. That is the only case that gives this. So, but for virtual image form in a convex mirror, image always lie between pole and focus. The image is never magnified. The image is diminished. You can see it's not magnified. The focal length is negative. No. Now, the focal length can be positive or negative depending on the convention used, on the sign convention. The convention you guys are used to from the junior classes is really positive. And what do you call it? Virtual is negative. It's a good convention, which is also applicable at A level to use it the same way. So, guys, this is it about that. The answer to that is Roman for 1, 2, 3, and 4. And I think option D is the right answer to that question. So we'll go to the last page, which is the last question for this wonderful stuff. And about the last question, we have question that says a boy looks into a plane mirror. Remember, image in a plane mirror has same size and same distance. Those are simple characteristics. It is never magnified. It is laterally inverted. In fact, in junior classes, if I draw a clock and I place a clock of 9 o'clock in front of a plane mirror, if I'm looking at the clock time, it will turn to what, 6 o'clock. I will, yeah, it will turn to 6 o'clock. You can try it out, you turn to 3 o'clock. You can try it because images. And the most important one you guys do very well is the usual when you have a plane mirror like that, image distance is always the same thing. If I have put maybe an alphabet of JP here, I want to write it as a give me something like PJ or whatever, which is what you talk about, inversion of a plane mirror and stuff like that in your junior classes. So it's always needed for you to what to be able to solve questions. You need to have the knowledge of junior classes. So if anybody is telling you that you don't need to know physics, you can just start from A level. No, it's not possible. You start from what? Basis of differentiation and integration. So by and large, my dear student, let's quickly solve this. A boy looks into a plane mirror, which is 3 meters away from him. So let's do a plane mirror. This is, then he looks into a plane mirror. Just draw anything I want to draw. It's not drawn to scale. Just want you guys to see. So let's draw a plane mirror like this. And we have this. Just for illustration's sake. It looks into a plane mirror which is 3.5 meter away from him. This is the boy. So 3.5 meter away from the plane mirror. If the boy is 3.5 meter away from the plane mirror, he's going to see the same distance of this particular thing will produce an image which is also 3.5 meter away. I hope you understand this. And he observes the image of the photograph, which is 1.5 meter behind his head. This is the boy. So now he is seeing an image of a what? Of his photograph. His photograph image is 1.5 meter behind his head. So behind his head will be something around here. So let's say this point is the point of 1.5 meter behind his head. The same distance. So it will also be what the image of this will also be 1.5 meter. I think these are simple stuff you might have studied before in your junior classes. And if not, just listen to my explanation. So the question is, what is the distance of the image from the boy's eyes? Oh, wow. So the distance of the image from the boy's eyes. Now, don't get what? Don't get this twisted. This is the boy. This was the what? The object, the photograph. I'll take it as P. Then this is the image of the photograph. Image of the photograph. Then this is the image of the boy's image. I just wanted to see this. So now if the question asks us what is the distance of the image from the boy? The distance of the image from the boy. Please, you need to be careful about this type of question. The distance of the image from the boy is like we are taking the distance from this particular point. See, I'm adding the value of 1.5 plus 3.5 plus 3.5. So please be careful. I'm adding from this particular point to this particular point. So we can say from here to here. From this particular point here to this particular point. For understanding says, so I'm looking for the distance of the image from the boy's eye. So image from the boy's eye. This is the image from to where the boy, this is where the boy is. So I'm looking at distance from here. You can see I bring it to here. So from here, 1.5 plus 3.5 plus 3.5. So the image will now be, this is 8.5 meters. So please understand this as one of your simplest questions. In fact, we can also talk about, but I don't think Ijmb or Waec are used to setting. You can move a plane mirror, you can move it. If you move it parallel, it will not change. If you move it perpendicular, it will change by twice the distance. The image will be twice the distance. All these things are not in your standard. I don't think I've seen any question of such, even in recent pattern. So the last question for this slide, which is a boy looks at the image of an object in a plane mirror. Everything is about mirror, 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 because we are talking about reflections. He observed two images, a main bright one and the other faint. The observed images result from dash. Very good. Now, students should be careful about this type of question. It's a simple question. Reflection, I said, takes place in mirror. So if you are using a plane mirror, we expect reflection. Reflection takes place in mirror. So reflection takes place in mirror. So refraction takes place in glasses. Reflection takes, or we'll say reflection and refraction takes place in glasses. I know why I'm saying that because of A-level student, so that I won't contradict myself. You need to understand that. So I can say refraction takes place in lenses now. In lenses. Because when we talk about glass slab, so you need to understand reflection and refraction. That is why you need to understand concept, reflection and refraction takes place in thick glasses. So once you thick glass, we call it about glass slab. So that is because we are going to do experiments of glass slab under the topic of refraction of light, talking about some important things, which is our day 13, which is the next in the syllabus. So guys, this is what I think Yeah, I'm going to stop for this particular section of the 12. If you find anything interesting, you can kindly subscribe and you can as well help us share the content to other platform whereby there are people out there that actually need to know all these things. So please do also favor by sharing the content to others. So thank you and see you guys soon. Bye for now.